Hi, thank you for watching my video. I am uploading my videos to share with you what impressed me on astrophotography activities. This is a demonstration video of how I make this time-lapse. You will see the effectiveness of software tracking and stacking frames for removing noise as well as flattening for light pollution reduction. The first thing to explain is the camera. I used Fujifilm X-T10. I used to use X1 Pro for this purpose, but I changed it because X-T10 has an electric shutter release, which is more reliable than X1 Pro mechanical one. Also, the tilted LCD helped me a lot. I didn't have to push myself under the camera that was pointing upward. I got a chance to capture so many frames throughout the night this summer. It was near new moon night. I set up the tripod and the camera like this. I also set up a Raspberry Pi HQ camera. I will upload another video about it sometime later. I captured more than 1500 frames throughout the night. I used 2 SD cards to capture everything. I used a mobile battery, DC converter, and battery coupler to feed the power for many hours. The next thing to do is develop a bunch of images. I used RawTherapee to adjust the tone curve and batch conversion. Then I used my Python program to transform the fisheye images to equirectangular images. Although I attached a leveler to the camera hot shoe, the image center was a bit off of the perfect vertical. I implement a way to adjust the horizontal plane as you see. After the conversions, my software tracking software does the Earth rotation correction. This is also a Python program utilizing PyQuilib library for the projection translation. In order to adjust the rotation axis, I set this Polaris mask overlaying to the north sky. I mean virtually inside the image. I set the date and time of the image taken. I adjust the rotation angle a bit so that the stars nearby also fit into the mask. Here, I set the shutter interval in seconds, enabled the software tracking, and set the number of averaging frames. The stationary Earth option is an interesting feature. When I make a time-lapse video, I can make either stars are moving just like we usually see, or stars are stationary so the Earth is tilting instead, and the image width is set to 4K resolution. Anyway, this averaging reduces the color noise significantly. The next thing is another enhancement. I use another Python program where flattening can be applied. The flattening is a high-pass filter, so the gradual background level change caused by light pollution is removed. It has a tone curve contrast adjustment feature as well. Finally, I got this time-lapse from consecutive images that were enhanced using the Python programs, using ffmpeg to do the job of making a video from images. I have been working on a separate project using these enhanced equirectangular images, compositing a full celestial spherical image from images taken in different seasons throughout a year. I hope I can report the outcome in a video in the near future. Okay, that's all for this time. Thanks for watching this video. See you next time.